Hello everyone, this is Alfio Sendo. Today let's go through some probabilistic fundamental and relative interview question in AI domain interview. If you like this video, please support me by subscribing my channel and click like for the video so more people can see my videos. You also can find the whole video list in video description below. First, let's go through some probabilistic fundamentals. So we'll denote P parentheses A as the event A probability occurrence probabilities. Then P not A means the event A won't be happens. The probability of the event A cannot be happens. Then of course the probability of A happens plus probability of A doesn't happens should be equal to 1. Then there is a conditional probability rule. If event A and B both happens, the probabilities can be calculated by probability of A given B multiply probability of B, or probability of B given A by probability of P A. Then for multiple event, we have chain rule for the conditional probability. So A, B, C both happens probability equal to A given B and C happens multiply P probability of the B and C happens. So here we just treat B and C both happen to the same event. Then P, B and C both happens can also be decoupled into P probability B given by C multiply P probability of C. I won't go into details to demonstrate the chain rule. So please feel free to try to demonstrate for yourself. Then based on the conditional probability equation, we can formulate Bayes' rule. If you look for the two later terms in the conditional probability, if we divide PB in both sides, then we obtain PA given by B equal to PB given by A minus P given A and divide by P probability of B. Then for multiple even Bayes rule, we have PA given by B and C equal to P probability of B given by A and C and probability of A given by C and divide by P probability B given by C. Next, we have the marginal probability rule. Basically says the probability of A event happens equal to another sub-event P A happens given by B multiply P probability of B. Then also plus PA given by not B multiply P given by part B. Then we plus them together. So it's easy to understand this. So this means A happens when either B can happen or B cannot happen, right? So then if we have PA given by B, then we want to multiply P probability of B to get P, A and B both happens. Then here is A happens, but B is not happens. Then we add them together because those are the only two conditions we can have. Then if we plus them together, we got the probability of P of A will always happen. Then also there is an independence event, which can be appear if A and B are independent given by C, so that if we want to calculate probability of both A and B given by C, we can separate them out independently by PA given by C and PB given by C. Okay, so next I'm going over to interview questions. So we will use some of the rule here so that we can understand when we should apply a specific rule and how to formulate a solution. First question. So Paris-Snow's probability is 1 about 4. Then now we have 3 people, A, B, C, say it's slow, but they lie. Probability is 2 about 3 independently. Means A and B and C also can lie at the same probability. Then what's the probability Paris snows if A, B, C both said it snows? Please pause here and try to think about your solution. Then we end up to solve this questions by using Bayes' rule and others probabilities theory. Here we denote snow as even as short name as S. Then of course you want to think about solve this in reverse order. So let me explain in reverse order to better understand how I formulate these answers. So right now, we want to know the probability of Paris as X snows if both A, B, C say snows. Then if I apply the Bayes rule, this can be calculated by A and B, C both say snows given by Paris snows and multiply Paris snows, then divide by A, B, C both snows probabilities here. Then we want to calculate each elements one by one. Then also based conditional, based on the marginal probabilities, you can calculate the probability for and A, B, C both say snows by A, B, C both say snows given by Paris snows and then multiply Paris snows. If you remember our marginal probabilities rules. Then also plus the same thing and the Paris not snow multiply Paris not snow. So first part I denote as 1 here. So follow up 1 can equal to, since A and B, C say snow is independence event regarding with A between A and B, A and C, and B and C. So we can apply the conditional independence conditional probability rule to separate them out. So first, A, B, C both say snow given by Paris snow can be separated as A says snow given by Paris snow and B says snow and X equal to snow, and also C equal to snow and X to snow marginalization together, which means multiplying together, and also multiply the second here Paris snow. So if we observe this term, we can realize this is exactly people lie probabilities, right? So then, so Paris is snow. Given Paris snow and A says snow, probability is 1 minus 2 observed, which means they didn't lie, right? So it's 1 above third here. Same thing for B, 1/3. C as well, 1/3. And then multiply the probability of Paris snow is 1 divided by 4. Eventually we get 1 over 108. Then for the second term, we're doing the same using conditional probability rule. Separate this as into 4 term. So first term, Paris is not snow, but A says snow. Exactly the probabilities they lie. So it's 2 above 3 multiplied triple times. Then the probability of Paris is not snow is 1 minus 1 over 4, right? So it's 3 over 4. Eventually we got 2 over 9. Then let's take a look for our Bayes rule again. For first term here, A and B, C both snow, given by Paris snow, which is the exactly the term here, right? So then we have his Paris given snow is 1 divided by 4. Actually, if we multiply them together, so we don't need to carry separately since we already calculate in term 1 here, right? In term 1. So we don't need to do this separately. Then what we got is 1 over 108. Then also for the probability of A, B, C, and all given by A, B, C are all say snow is calculated by the marginal probability rule here. So eventually we can solve this whole Bayes rule to obtain our final answer if both A, B, C is snow, but the probability of Paris snow. Okay, so now let's look at the second question. You're given a bag of 100 coins with 99 fair ones. Flipping, which means those fair ones, when we flipping heads and tails, are 0.5 probabilities for each. And we also have one unfair coin, which flip heads with 1.0 probabilities. So when we flip the unfair coins, we always obtain heads. So now you pick a coin randomly from those 100 coins and flip 10 times. Then you're getting heads every single time. Then what's the probabilities you pick the unfair coins when you obtain this event? Basically says if you pick a coin randomly, right, then flip 10 times, you're always getting heads every single times. Now, what's the probabilities the coin you have is an unfair coin? So please think about how you solve this solution and hit the pause button. I'll show the answer later. Okay, so this is our answer. If we denote event A, which is the event of pick the unfair coin, and event B as event of flip 10 heads in a row. Now, the final solution of this question we want to obtain is probability of A given by B, right? So the probability is we pick the unfair coin, given the truth is that the event of flip 10 heads in a row. Then applying the Bayes rule, P given by B, A given by B, P A, and here, so basically this is written by P A and B. Right now, we have A and B. Now eventually we can sorry, so this should be let me do it again. This should be P probability of B, right? So then based on our marginal probabilities, we can write PB in P A given B multiply PA plus PB and not A multiply P not A. Then let's look at Bayes rule, how many probability we already can obtain or being calculated. For P, B given by A, so this is 1.0, right? So if we pick the unfair coin, of course, the event of flip 10 times always heads. For this probability is always 1.0. Then probability of A, which means the probability of picked unfair coin. Since we have 100 coins and one is unfair, so the probability is 0.01. What's next? We have P being A, and we also have PA. So, and we want to know probability of P given by not A. So then let's understand this. Which means if we pick a fair coin, what's the probability of 10 heads in a row? Then since this 10 times is conditional independence, so we apply the conditional independence rule. So each times it's head, the event is the head, the probability is 1/2, right? Since it's a fair coin. So then we multiply 10 times. So then it's 1 above 2 multiple 10, factor of 10. So the only thing we left right now is P of not A. P of not A is easy, just the 1 minus P of A is 0.99. Eventually, we put all the known value into this equation. We will obtain the 0.9118 as our final answer. All right, so those I have covered all I want to talk today. Hopefully you got more understanding about the probabilities rules and how it applies. See you in next video.